Hello everyone, this is Pragya Shrivastava, an educator on Unacademy. Follow me on Unacademy Learning app where you'll find my many more courses. Do rate, review and share my lecture. Your review means a lot to me. And in this lesson, we'll be studying about Terzaghi's Bearing Capacity Theory analysis. For his analysis purpose, Terzaghi made some important assumptions. He carried out his analysis on a strip footing. Strip footing, that means it is actually very, very long. That means length upon width is normally taken to be more than 5, and the length may extend up to infinity. He carried on his analysis on a shallow foundation where depth of footing upon weight is less than 1. And an important assumption he made is that weight of soil above the base of footing can be replaced by a uniform surcharge gamma dF, which is actually not the case. He assumed that the shear strength of soil above base of footing is neglected. That means the soil is possessing no shear resistance to your base of footing. Then he assumed that the footing base is rough, and then the shear strength of the soil is governed by Moore-Coulomb's equation. Now here is the arrangement. Suppose this is your footing. This is your ground level. This is going to be the depth of footing. And these are the different zones under the action of the vertical load. This is your loading, which is actually uniformly spread over the area. And below your footing, what you see that the soil profile looks like this. This is your failure zone. And I have marked the different parts as this part is zone 1, this one, and this one is your zone 2, and here is your zone 3. The angle which it makes is actually 45 degree minus pi by 2. What is your zone 1? Zone 1, it has been differentiated on the basis of, this is your elastic zone. Zone 2 is the zone of radial shear, and zone 3 is your Rankine's passive zone. PP is the passive pressure, for which we have already studied about it in soil mechanics. This in zone 3, passive pressure is working, and I have taken the length of inclined surface here, Li. And now what? To our analysis, I have drawn the free body diagram of this wedge here, and let's see what are the different forces that may be acting on this wedge. The first is your QU, the surcharge load, then W, the weight of your footing, and on the inclined surface, here what you see, a passive pressure will be occurring here. A passive pressure is acting here as well. And these are the cohesive forces, because taking it as a normal C5 soil. And this is the free body diagram of your wedge. Let's see the total forces that may be acting on the wedge. The downward forces is the load QU acting over a width B. So the total load is actually equal to QU cross B. Then weight of the wedge is also acting here. Weight of the wedge W is actually equal to half gamma B square tan phi. Then there is upward forces. Upward forces are PP. There are two PP you can see here. and because I am considering the whole wedge, stability of this whole wedge, so I'll have actually 2 times PP acting, giving you an upward force. There is cohesion C. C is equal to CLI sin phi. CLI sin phi is the total length of this portion, and the cohesive force, vertical cohesive force, is CLI sin phi. And you can easily see that there are 2 C's acting. The cohesion is taken in both the direction. 2 C's are actually acting. So when on resolving in the vertical direction, you'll have 2 CLI sin phi, because of this is the force because of cohesion. So your equation actually looks like this. Failure occurs when downward pressure is actually equal to upward pressure. For equilibrium, I am actually equating these two. What we get? So what your equation looks like this: 1 by 4 multiplied by gamma b square tan phi, the weight, plus QU cross B, the load, is actually equal to 2 times PP, the passive pressure, plus this is the cohesive force that is actually acting upward, 2 Li sin phi. This can be further reduced to QU cross B is actually equal to 2 PP plus BC tan phi. I have reduced this as BC tan phi, taking that Li is actually equal to B by 2 upon cos phi. Li, converting it in terms of B by 2 cos phi. So your equation looks like this: BC tan phi, then this term, bring it here. This is actually equal to 1 by 4 gamma b square tan phi. So your equation looks like this: QU cross B is equal to 2 PP plus BC tan phi minus 1 by 4 gamma b square tan phi. And now again, let us analyze it further. The resultant passive pressure PP. PP is actually equal to sum of PP gamma plus PP C cohesion plus PP Q because of loading. The passive pressure consists of 3 components: 1 because of your soil, and second because of cohesion, and third because of the loading. And PP gamma is actually the passive pressure due to weight of stress zone when assuming C is equal to 0 and neglecting the surcharge Q. That means independent of C and Q, just PP gamma is the pressure because of the weight of shear zone. Then PPC is due to cohesion of soil, unassuming gamma to be equal to 0 and neglecting the surcharge Q. In similar fashion, PPQ, because of the pressure produced due to the surcharge, it is actually found out assuming C to be equal to 0 and gamma is actually equal to 0. Now the bearing capacity equation looks like this: QU cross P is equal to 2 PP plus BC tan phi minus 1 by 4 gamma B square tan phi. Can be PP is replaced by this portion and equation remains same. And if you substitute 2 PP gamma minus 1 by 4 gamma B square tan phi, PP gamma minus 1 by 4 gamma B square tan phi by B cross 1 by 2 gamma B N gamma. I have introduced the term N gamma here, and NC and NQ, and 2 times PPC plus BC tan phi is taken to be equal to B cross C and C, and 2 2 times PPQ is equal to B cross gamma DF and Q. If you replace this, you will get an equation which is like this. QUB is equal to BC and C plus B gamma DF and Q plus B cross half gamma B N gamma. And this equation, you can easily cancel the B from all the parts. So you get QU is equal to CNC plus gamma DF and Q plus 0.5 gamma B N gamma. So this equation is nothing but your bearing capacity equation. But what is NC N gamma? Let's see. And NQ, these are dimensionless numbers depending upon the angle of shear resistance and are called bearing capacity factors. The values of NC is actually equal to cot phi A square upon 2 cos square 45 degree plus phi by 2 minus 1. The value of NQ is actually equal to A square by 2 cos square 45 degree plus phi by 2. And your value of N gamma is actually equal to 1 by 2 Kp upon cos square phi minus 1 tan phi. What is A? A is actually equal to e raised to power 3 pi by 4 minus phi by 2 multiplied by tan phi. And what is Kp here? Kp is the coefficient of passive earth pressure. And this has actually been done for some convenience because the values of NC, NQ and N gamma are tabulated in both cases, for a case of general shear failure and for a case of local shear failure, and can be used directly from that table. So for our convenience and to make our calculation work easy, these terms NC, NQ, N gamma has been introduced, which are nothing but bearing capacity factors. Please try to go through this lesson and understand the bearing capacity. It's important from your exam point of view. You're always going to get some question from this chapter. You need to be very thorough with the different terminologies of the bearing capacity, net bearing capacity, ultimate bearing capacity, and the formula that we actually obtained from Terzaghi's analysis. Go through it and have a nice day.